Hello students, how are you all? I am Gurmeet Singh and welcome you to CREATA classes and also welcome to our complete series on trigonometry for class 10 student. In this lecture or in this series, we will cover all these lectures using the power of visualization. You will love our unique way of teaching. Apart from this lecture, we are also having a complete PDF of the formula and concept list. Check out the link in the description. And we also have the cues related to the various trigonometric questions. To check the level of your understanding of the concept, check the link in the description. And especially in this lecture, we will cover the exercise 8.1, question number 7 to question number 11. If you want to practice more questions, check out the quiz. The link is in the description where you will find the questions related to trigonometry. You can practice more questions there. And without taking any further time, let's start with this lecture. Best of luck, and here is the lecture. Question number 7 is, if cot theta is equal to 7 by 8, evaluate. Two parts are given. Let's check one by one. Firstly, let's check a triangle ABC which is right angled at angle B. Here angle A for this triangle is angle theta, and angle theta is a trigonometric angle for this question. How we know that? If you observe, all the trigonometric ratios given in this question is having angle theta as a trigonometric angle. And angle theta is angle A, so we can say our angle A is a trigonometric angle for this question. All the trigonometric ratios we will calculate with respect to this angle theta, that is angle A. Got it? Let's move further. In the question it is given as cot theta is equal to 7 by 8, and we know what is cot. Cot is base upon perpendicular. We know cot is reciprocal of tan and tan is perpendicular over base, so cot will be base over perpendicular, the reciprocal of tan theta. Okay, so basically we need the trigonometric side, that is what is base and what is perpendicular and what is hypotenuse. Let's see. Here our trigonometric angle is angle A, that is theta, and the side opposite to the trigonometric angle is the perpendicular. So BC is perpendicular for this triangle. Okay, BC we got as perpendicular as it is opposite to trigonometric angle theta. Further, angle B is 90 degree and the side opposite to 90 degree angle is the hypotenuse. So the side AC for this triangle is the hypotenuse. And the last remaining side AB is the base for this triangle with respect to trigonometric angle theta. We have identified all the three trigonometric side. Let's proceed. Cot theta is 7 by 8, which is base upon perpendicular, and base is AB and perpendicular is BC. So we got AB upon BC is equal to 7 upon 8. Got it? Moving further, here AB is not equal to 7 and BC is not equal to 8. We will apply the same concept that we have covered in the question number 3 and 4. We will assume AB as 7 times k, that is 7k, and BC as 8k. Got it? Where k is a positive number. The same concept we have applied in the previous questions we have applied here. If you want to refresh the concept, check out the question number 3 and question number 4 of the same exercise. The link is given in the description. Moving further, we got two sides of this triangle as 7k and 8k. Let's find the third side using the Pythagoras theorem, which is AC square is equal to AB square plus BC square. AB is 7k and BC is 8k. Let's put the value. On solving, we got AC square is equal to 113k square, which is AC is equal to k root 113. So we got AC, or the hypotenuse of this triangle, as k root 113. So basically we got all the three sides of this triangle, AB, BC and AC, that is base, perpendicular and hypotenuse. Now we can easily find any of the trigonometric ratios. In the first part, we have to calculate the value of the given equation, which involve two trigonometric ratios, which are sin theta and cos theta. So let's find sin theta and cos theta. Sin theta, it is perpendicular over hypotenuse, which is BC upon AC, that is 8k upon k root 113. On solving, we got sin theta as 8 upon root of 113. Got it? Let's find cos theta. Cos theta is base upon hypotenuse, that is AB upon AC, which is 7k upon k root 113. On solving, we got cos theta as 7 upon root of 113. We got sin theta and cos theta. We can directly put the value of sin theta and cos theta in the equation to get the final value. As an alternative, if you observe the equation, here can we write 1 plus sin theta into 1 minus sin theta as 1 minus sin square theta? Yes, we can do so. I have simply applied the formula of a plus b into a minus b, that is a square minus b square. So we got 1 minus sin square theta in the numerator. Similarly, in the denominator, we can rewrite 1 plus cos theta into 1 minus cos theta as 1 minus cos square theta. So we got 1 minus sin square theta upon 1 minus cos square theta. We know the value of sin theta and cos theta. Let's put the value. Let's square the term. Let's solve it. 113 will cancel out. On solving, we got our answer as 49 upon 64. That is the answer of first part of this question. Got it? 49 upon 64. Let's move to the second part. In the second part, we have to calculate the value of cot square theta. And in the question, cot theta is given as 7 by 8 and cot square theta will be equal to 7 by 8 whole square. Let's do the squaring. We got the answer as 49 upon 64. That is the answer of this question. Got it? Just note that answer of both the part is 49 upon 64. This is the beauty of NCERT questions. They always give us hint of the next part of the chapter. In the next part, we are about to do the trigonometric identity. And the formulas of trigonometric identities are also applicable in this question. 1 minus sin square theta upon 1 minus cos square theta on solving through the trigonometric identity will give the answer as cot square theta. That you will see in the next part. But my advice to you, once you have completed the trigonometric identity, which is the next part, again come back to this question and try to solve it. You will understand the beauty of NCERT questions. Okay? So we have done with this question. Let's move to next question. If 3 cot A is equal to 4, check whether 1 minus tan square A upon 1 plus tan square A is equal to cos square A minus sin square A or not. So let's observe the question. In the question, we are given 3 cot A is equal to 4. That is cot A is equal to 4 upon 3. And we have to check whether the left hand side and right hand side of this equation are equal or not. Basically, using cot A, that is 4 by 3, we have to find the value of sin A, cos A and tan A. And we have to put the value in the equation. Then we have to cross check left hand side and right hand side are equal or not. So let's approach the question. For that, let's take the triangle ABC, which is having angle A as a trigonometric angle. Again, why we have taken angle A as a trigonometric angle? Because in the question, all the trigonometric ratios are with respect to angle A. So angle A is a trigonometric angle. Firstly, let's identify the perpendicular base and hypotenuse. Perpendicular is the side opposite to trigonometric angle, so BC is the perpendicular. AC is the hypotenuse as it is opposite to 90-degree angle, and AB is the base, that is the third remaining side. So let's proceed. Here cot A is given as 4 by 3. And we know what is cot. Cot is base upon perpendicular. If you know tan A as perpendicular over base, you can do the reciprocal. You got cot as base upon perpendicular. And base for this triangle is AB and perpendicular is BC. So we got AB upon BC is equal to 4 upon 3. So we will use the same philosophy we have used in the previous questions. Let's take AB as 4K and BC as 3K, where K is a positive number. So we got AB as 4K, that is the base, and BC as 3K, which is the perpendicular. We got two sides of the triangle. Let's find the third missing side, that is the hypotenuse, using the Pythagoras theorem. AC square is equal to AB square plus BC square. Let's put the value 4K and 3K. On solving, we got AC square is equal to 25K square. That is AC is 5K. So we got the hypotenuse for this triangle as 5K. That is the AC. So we got all the three trigonometric sides for this triangle. Now we can calculate any of the trigonometric ratio. In the given equation in the question, we have to find sine, cos and tan. So firstly, let's find sine A. Sine is perpendicular over hypotenuse, that is BC upon AC, which is 3k upon 5k. So we got sine A as 3 upon 5. Got it? Very simple. Let's find cos A, which is base upon hypotenuse, which is AB upon AC. AB is 4k, AC is 5k. We got cos A as 4 upon 5. We got sine and cos. Let's find tan A. In two ways we can find the value of tan. Tan is perpendicular over base, that is BC upon AB. We got BC as 3k, AB as 4k, so we got the value of tan A as 3 upon 4. Got it? This is the first way. Let's check out the second way. We know tan is sine upon cos. The ratio of sine and cos is tan theta or tan A in this case. So tan A is sine A upon cos A. We can divide sine A and cos A to get the value of tan A. Let's do so. 3 by 5 upon 4 by 5. We got the answer as 3 by 4. So you can use any of the way to solve for tan A. But note that you should know all the different approaches to solve the question. This is really helpful in the mid of the examination. Okay. So we got all the three trigonometric ratios given in the question. Let's find the left hand side first. That is 1 minus tan square A upon 1 plus tan square A. Tan A is 3 by 4. Let's put the value. Let's solve it. Here 16 and 16 will cancel out. We got our answer as 7 upon 25. Left hand side we got as 7 upon 25. Let's find right hand side, which is cos square A minus sin square A. Cos A is 4 by 5, sin A is 3 by 5. Let's solve it. On solving, we got the value as 7 upon 25. So we got left hand side is equal to right hand side. So this equation is true. Okay, we have proved the same. And that is also the answer of the question number 8. Got it? These all questions are related to trigonometric identity. Once you have done the trigonometric identity, my advice is that again come to this question and solve using the trigonometric identity formula. It will be really interesting. Okay? Let's move to question number 9. In triangle ABC, right angled at B, if tan A is equal to 1 upon root 3, find the value of. Two subparts are given. Let's take one by one. Firstly, let's take the triangle ABC, our usual triangle, which is having 90-degree angle at angle B. If you observe the trigonometric ratios given in the question, we are having two trigonometric angles. Angle A is a trigonometric angle in some part and angle C is also the trigonometric angle in some part. So basically here we have to find the trigonometric ratios with respect to two different trigonometric angles. Note that identification of the trigonometric angle is the first step that you should do. So let's approach the question. Firstly, let's see what is given in the question. In the question, it is given as tan A is equal to 1 upon root 3. Here the trigonometric angle used is angle A. That is the first step. Let's mark angle A as a trigonometric angle. Second step, we will identify the trigonometric sides, that is perpendicular, base and hypotenuse with respect to the trigonometric angle. Here BC will be the perpendicular as it is the side opposite to trigonometric angle, and hypotenuse is the side which is opposite to 90-degree angle, so AC is the hypotenuse, and the third remaining side AB is the base. Okay. Further in the question it is given as tan A is 1 upon root 3 and we know tan is perpendicular over base. That is BC upon AB is given as 1 upon root 3. We will use the same philosophy we have used in the previous question. Let's assume BC as K and AB as K root 3. Okay, the same fundamental we have applied in the question number 3 and 4. The same fundamental we have applied here. So we got two sides of this triangle, that is perpendicular and base. The hypotenuse is still missing in the question or in the triangle. How we will find the hypotenuse? We will apply the Pythagoras theorem. AC square is equal to AB square plus BC square. Let's put AB as K root 3 and BC as K. Let's solve it. We got AC square is equal to 4K square. That is AC is 2K. That is the hypotenuse. So we got all the three sides of this triangle. That is the trigonometric sides. Let's find the trigonometric ratio. With respect to angle A as a trigonometric angle, we are having sine A and cos A. Let's find sine A and cos A. Sine is perpendicular over hypotenuse. So sine A will be equal to BC upon AC, and BC is K and AC we have calculated as 2K. So we got sine A as 1 by 2. Got it? Let's find cos A. Cos is based upon hypotenuse, which is AB upon AC. Let's put the value. We got cos A as root 3 by 2. So we got sine A and cos A. Further, if you observe the question, we have to calculate sine C and cos C. We have just calculated sine A and cos A. Now we will calculate sine C and cos C. It means our trigonometric angle has been changed to angle C. Okay. First step, let's identify the new trigonometric sides. Which side is the perpendicular with respect to trigonometric angle C? AB is the perpendicular. AB is the perpendicular as it is opposite to trigonometric angle C. And hypotenuse remain the same, that is AC is the hypotenuse opposite to 90-degree angle, and the third remaining side BC is the base. So we got the trigonometric sides. Let's find the trigonometric ratio. Firstly, sine C. Sine is perpendicular over hypotenuse, that is AB upon AC, which is K root 3 upon 2K. K and K will cancel out. We got sine C as root 3 upon 2. We got sine C. Let's find cos C, which is based upon hypotenuse, and base is BC and hypotenuse is AC. Let's put the value K upon 2K. We got cos C as 1 by 2. So we got sine C and cos C, and previously we have calculated sine A and cos A. Now we can put the value in the first part. Let's check it out. Sine A cos C plus cos A sine C. Sine A is 1 by 2, cos A is root 3 by 2, sine C is root 3 by 2, cos C is 1 by 2. On solving, we got the value as 1. So the answer of first part is 1. Sine A cos C plus cos A sine C is equal to 1. Let's move to the second part. In the second part, we have to calculate the value of cos A, cos C minus sine A into sine C. We know all the four values. Let's put the values. On solving, we got the answer as 0. Cos A cos C minus sine A sine C is equal to 0. Okay, we have done with both the parts. We have done with question number 9. Let's move to question number 10. Students, an important thing for you, check the description for the PDF of the complete formula list and also the link to the quiz. Use the formula list to brush up the concept before the exam and the quizzes to check your preparation before the exam. The link to both the formula list and the quizzes are given in the description. Check it out. So let's back to the lecture. In a triangle PQR, right angle at Q, PR plus QR is equal to 25 cm and PQ is equal to 5 cm. Determine the value of sin P, cos P and tan P. Let's observe the question. In the question, a triangle PQR is given, which is right angled at angle Q. That is, angle Q is a 90-degree angle. Further in the question, it is given that PQ is 5 cm. And also a small equation is given, that is PR plus QR is equal to 25. Note that whenever such type of equation is given, these equations will be helpful in the Pythagoras theorem to solve for the missing sides. Note that this will be helpful. So PR plus QR is given as 25 cm. Further, we have to find sin P, cos P and tan P. Here the trigonometric angle given is angle P. Okay. Basically, the question is asking us to find the trigonometric sides. Once we find the trigonometric sides, we can easily find the trigonometric ratio. Note that here the trigonometric angle is angle P. That is important. So let's approach this question. Here PR plus QR is given as 25 cm. Can we rewrite PR as 25 minus QR? Yes, we can do so. Further, this is a right angle triangle, so we can apply the Pythagoras theorem. That is, PR square is equal to PQ square plus QR square. And just now we have calculated PR as 25 minus QR. And PQ is also given as 5 centimeter. Let's put the value in the equation. If you observe, only the missing term in this equation is QR. Let's solve for the QR. Let's open the square. Here QR square and QR square will cancel out. Let's further solve it. We got the value of QR as 12 centimeter. So we got the two sides of the triangle. Let's find the third missing side, that is PR. In the equation, PR plus QR is given as 25 centimeter, and just now we have calculated QR. Let's put the value. On solving, we got PR as equal to 13 centimeter. Okay, simple calculation. Now we got all the three trigonometric sides of this triangle. Firstly, let's identify what is perpendicular, base and hypotenuse. Here QR is a perpendicular as it is opposite to our trigonometric angle, angle P. And hypotenuse is PR as it is opposite to our 90-degree angle. And PQ is a base, that is the remaining side. Okay. Let's move further. In the question, we have to find sin P, cos P and tan P. Firstly, let's take down sin P. Sin is perpendicular over hypotenuse, that is QR upon PR, which is 12 upon 13. We got sin P as 12 upon 13. Okay. Let's take down cos P. Cos is base upon hypotenuse, which is PQ upon PR, which is 5 upon 13. So we got cos P as 5 upon 13. Okay. Let's find the last trigonometric ratio, that is tan P, that is perpendicular upon base, which is QR upon PQ, which is 12 upon 5. So we got tan P as 12 upon 5. You can also find tan P using the alternative approach, that is tan is sin upon cos. We have already calculated sin P and cos P. You can put the value. You will get 12 upon 5. That is the same answer we have got using the formula of tan. Okay. So that is the answer. We have calculated all the three trigonometric ratios. We have done with the question number 10. Let's move to question number 11. State whether the following are true or false. Justify your answer. This question is having 5 parts. Let's take one by one. The first one, the value of tan A is always less than 1. We have to state whether it is true or false and justify our answer. Let's see. Let's take our usual triangle, triangle ABC, which is right angled at angle B. Here angle A is a trigonometric angle. AC is the hypotenuse, BC is the perpendicular, and AB is the base with respect to the trigonometric angle, angle A. Further, we know the formula of tan as perpendicular over base, that is tan A is equal to perpendicular over base. If we talk about the trigonometric sides for this triangle, you must be knowing that hypotenuse is the longest of three trigonometric sides. That is, among perpendicular, base and hypotenuse, hypotenuse will be longest. And among perpendicular and base, which is greater, perpendicular can be greater than base or base can be greater than perpendicular. It does not matter. Only the fact is that hypotenuse is greater than perpendicular and base. Hypotenuse is the longest one. This fundamental will be used in solving this question. Here tan is perpendicular over base. Hypotenuse is not involved in this formula. So let's take two cases. In the first case, perpendicular is greater than base. In the second case, base is greater than perpendicular. Then let's see whether we are getting the value less than 1 or greater than 1. In the first case, perpendicular is greater than base. Here the value of tan will be greater than 1. Okay, perpendicular is greater than base, so the value of tan will be greater than 1. In the second case, base is greater than perpendicular. Here the value of tan will be less than 1. So we got that the value of tan can be greater than 1 or less than 1. So this statement is false. That is, the value of tan A is always less than 1 is false. And that is the answer of the question. Tan value can be greater than 1 and tan value can be less than 1. Got it? Let's move to second part. Sec A is 12 upon 5 for some value of angle A. Let's see whether this is true or false. We know the formula of sec as hypotenuse upon base. If you do not know, you should know the formula of cos, which is base upon hypotenuse. And sec is just the reciprocal of cos. Cos is base upon hypotenuse, so sec will be hypotenuse upon base. Okay? And in the question it is given as sec A is 12 upon 5. 12 correspond to hypotenuse and 5 correspond to base. Hypotenuse is the largest of all the three sides, so yes, it is true. Hypotenuse corresponding to 12 and base is corresponding to 5. 12 is greater than 5, that is hypotenuse is greater than base, so it is true. Sec A can have value of 12 upon 5 as hypotenuse is always greater than base. So this statement we got as true. Let's go to third part. Cos A is the abbreviation used for cosecant of angle A. This is not true. Cos means cosine and cosec means cosecant. Okay, cosine is cos and cosecant is cosec. These two terms are generally confusing. You should note that. Refer the PDF of the formula and the concept list. You will find the detail of all these trigonometric ratios in that. Okay, the link is in the description. Check it out. Let's move to fourth part. Cot A is the product of cot and A. This is also the general point of confusion. Cot A does not mean we are multiplying cot with angle A. Cot A means the trigonometric ratio of cot with respect to trigonometric angle A. This is also false. Let's move to fifth part. Sin theta is equal to 4 by 3 for some angle theta. Here our trigonometric angle is angle theta. And we know what is sine. Sine is perpendicular upon hypotenuse. And hypotenuse is the largest of all three sides. Here 3 is corresponding to hypotenuse and 4 is corresponding to perpendicular. So it is showing that hypotenuse is smaller than perpendicular, which is not true. Hypotenuse will always be the largest of all three sides. So this statement is false. Sine cannot have value of 4 by 3. Hypotenuse will always be larger than the perpendicular. Okay, we have done with the fifth part, that is we have done with the question number 11. So students, that's it for this lecture. Hope you have enjoyed our creative way of teaching. If you have enjoyed this lecture, if you have gained anything out of this lecture, please like, share and subscribe to our YouTube channel, that is CREATA CLASSES. We add creativity to the learning. And note that this lecture is part of the complete series on trigonometry for class 10 student. The link to the other lectures are given in the description. Check it out. And apart from this, also check out the PDF of the complete formula and concept list and also the quiz related to trigonometric questions, where you can check the understanding of the trigonometry and the questions. So that's it for this lecture. Bye for now. Best of luck for the exam you're preparing for and have a great day. Bye.